everybody, and welcome to today's topic of integration. We're going to be doing trigonometric and exponential. This is a part of AdMath syllabus only. This is not done in AS syllabus. Okay, so first of all, let's look at trigonometric. Okay, so integration is basically the opposite of differentiation. So when we differentiated sine x, it would give us cos x. So now that we're integrating cos x, it will give us sine x, but we'll also have a constant here, because you get a constant in integration. So similarly, when we differentiated cos x, we would get minus sine x. But and if we differentiated minus cos x, we would get sine x. So now that we integrate sine x, we'll get minus cos x. So you can remember this by that when you differentiate it, you get a positive cos x, but when you integrate it, you get a negative cos x. So these two are basically the opposites of each other, and these two are the opposites of each other. But you also get a constant here in both cases. Okay. Similarly, when we differentiated tan x, we will get sec square x. Now that we integrate sec square x, we'll get tan x plus a constant. Okay, now that then when we differentiated sine ax, so this angle would its differentiate would multiply with the differentiate of this whole thing. Okay, so for example, sine ax would be written as a cos ax, and when we integrate this cos ax, so it'll be the opposite. So instead of multiplying, we'll divide it. So 1 upon a sine, this will be sine ax plus c. So this will basically be the opposite of differentiation. So let's take a look at the examples of this. All right, so in this question, we have to integrate cos 3x. So we know that the differentiate of cos was minus sine x. Uh, so the integrate of cos will be sine x, because it's the opposite. All right, this is negative, this is positive. So we can write this as sine 3x. But because this is integration, we divide it by this, so 1 upon 3, and then we apply the powers, these limits actually, and this will give you the result 1 upon 3. Okay, now let's take a look at another example. Alright, so this is a tricky question. They've given us 1 upon cos square x upon cos square x, and we have to integrate this, and we have to show that it is equals to this. They've also given us limits. So first of all, we'll simplify this, because we have not learned how to integrate cos square or any of the squares. So that is something far beyond the syllabus. Okay, so we can simplify this by writing 1 as sine square x plus cos square x, and the remaining cos square x can come like that, and cos square upon cos square x. So this will give us sine square x plus 2 cos square x upon cos square x. Now if we break it up, this will give us sine square x upon cos square x plus 2 cos square x upon cos square x. So cos square x gets cancelled. Sine upon cos is tan, so sine square upon cos square will be tan square x plus 2, and we have to integrate this. So there is a identity which will be written in your question paper, which is 1 plus tan square is equals to sec square. So we have tan square plus 1, this will become sec square plus 1, and you have the limits pi upon 4 and 0. You'll first of all integrate this. So this integration of sec square x is tan x, and the integration of 1 is x. So you have pi upon 4 and 0. So we'll put in the limits. So tan pi upon 4 is equals to 1, and x, we put this in x, so this will give us pi upon 4, and tan 0 is 0, so this gives us pi upon 4 plus 1, which equals to the result we had to find it equal to. Okay. Okay, so now let's take a look at exponential integration. So when we differentiated e to the power x, it would give us e to the power x, because this 1 would come down here, multiply with e, so 1 e to the power x would remain the same. So similarly, it would remain the same in integration as well. You'll just get a constant. But if you have an integer greater than 1 here, that will come down here, multiply with e. And similarly, when you do integration, it's the opposite. So instead of multiplying, we'll divide it by that. Obviously, a cannot be 0 because 1 upon 0 is undefined. And you'll also get a constant here. So let's do a question of this to understand it better. Okay, so in this question, we've been given a function. We have to actually find a function. We've been given the dy upon dx, and we've been given two values. When y is 6, we have x as ln 3. So first of all, to find the y, we have to integrate dy upon dx, which is e to the power 2x. Now we've learned that when we integrate something e to the power 2x, we divide by the integer in the power. So e to the power 2x, and you'll also get a constant because you don't have limits in this. Okay, so but now that you've been given certain coordinates, you can put in that coordinates and you can find the value of c. So y is 6, 1 upon 2 e to the power 2 into ln 3 plus c, and c is equals to 6 minus 9 upon 2. This turns out to be 9 upon 2, and you get c as 3 upon 2. So you can write the equation as 1 upon 2 e to the power 2x plus 3 upon 2, and there is the answer. So that was all from integration. This was only a part of add math. It's not a part of AS syllabus, so that's why it had to be in a separate video. Thank you for watching. Goodbye.